Okay, today I don't have a ton of time, but I have some. So I'm going to try getting some programmatically created textures into Blender so that I can experiment with using HealPy for equal area latitudinal projections. Did I get that right? Hierarchical equal area. Yeah. All right. So let's go to the code view. So I'm going to start with experimenting out by creating some arrays. Oh, also I set up a soundboard, so if anything super cool happens, I'm going to hit it with a sound. Alright, we're going to experiment first. So I'm first creating a new script here, HealPix texture. I'm going to create a new array, and in advance of this, what I did was I used Blender to pip install HealPy, SymPy, and SciPy. So let's go ahead, we'll create our array as a buffer, 4 times width times height, and I will set every fourth starting with 0 to 1, so that should be all the reds, every 30th to 1, so that's all the alphas. Then I create a new image, and then I set using for each underscore set array. So this is what it ends up looking like, but I'm going to start Blender over to see what it looks like here. Okay, so let's go on over into scripting, open. So when I run this in this, what it will do is it creates a new unassociated image. Okay. It's called example image. Now, this is going to be something we're going to update in just a minute. So let's go back here to layout. I'm going to add an empty image object. Now that empty image object, I will come over, let's get rid of my cube. Is it about my cube? I'm going to go to the empty image object. Let's get rid of these needle items. And let's see, I believe it's here under data. Yeah. Now I can click here on the drop down, and I've got my example image. So that's the first thing. It's fully red. Now let's try a couple other things. We're going to start by saying np array 4. So here, we'll do np.mgrid 0.0, 0.0 to 1.0 width times 1j, 0.0 to 1.0 height times 1j. And so now this is going to give us our red, and I guess we'll do blue. So this will give us 1024 by 1024, I'm sorry, 1024 by 640. And just to show you what that looks like, import numpy as np, mgrid 0.0 to 1.0, 1024j. That gives us 1024 steps that go inclusive from 0 to 1. And if we add on a second dimension, it'll give us 2. Okay, so we can then unpack those. RG is equal to that. R.shape, 1024 by 640. G shape, 1024 by 640. So instead of doing 4 times width times height, we will do width, height, and then actually we can still do this. Width times height times 4. It'll be a little bit easier to do it this way. We will say now array every fourth starting at 0 is equal to x.ravel. Now we will set our green, so red, green, and now just for clarity's sake, and this will be y, alpha. Okay? So now we go back to Blender, and we will get rid of this step in just a minute. But we select our render node here, and we or we select our example image, we delete it. We'll come back to that in just a minute. We reload this script, we run it, we've got our example image again. So now let's go back over to layout, take empty, and update the image that it uses to use this. You'll see there it is. Now, looks to me like maybe we've got a row column ordering issue here. So let's see. So let's do width height 4. And there's probably a way like specify D type. Yeah. So now let's do array 0 is equal to x 1.0, y 0.0. And now let's see, for each set array ravel. So this will flatten the array. That gives us a little bit more to work with. So let's go back into our scene, example image, delete, reload our script, rerun it. Now we've got our example image back. Let's go back here to our empty. So it looked the same. So let's try raveling it in Fortran order, which is not the default, but that's where the final dimension varies the quickest. So let's go here to scripting, example image delete, reload, rerun, layout, layout, change my image here. See now, ooh, that doesn't look right at all, does it? So here's the other possibility, that our width and our height are backwards. So it's possible that it needs to be in row major, but with the 4 bytes sequential. So let's go back here, scripting, reload, delete render, or delete our image, rerun, go to layout, change our image to example image, and there we go. All right, so that's pretty clear. We need it to be in Fortran order for the dimensions, but not for the byte ordering. Okay, so let's get back to generating our procedural textures. Okay, so the first thing we are going to do is let's see what happens if we map this onto a cube, or onto a sphere. So let's do geometry nodes, create a new one. Let's add a cube here. I'm actually going to get rid of my empty image. Okay, so we've got this. Now let's go to our cube. And what we're going to do is we're going to do a real quick subdivision of it so that it has lots and lots of vectors. And if we look at this in wireframe, you'll see, yep, lots and lots of vectors. Probably just put it down at 5, maybe even 4. And we'll do the trick we came up with before. We take our positions, vector math, and then instead of allowing our vectors there to be just what they are normally for the positions, we're going to set our position to be the normalized version of those vectors. And so that gives us a sphere. So this is a neat trick that I learned the other day. Maybe it's not even a trick. Maybe it's just how you're supposed to do stuff that I found to be really, really useful and very helpful. So we've got this. Now, let's shade it. And the first thing I'm going to try doing is we're going to set a material. Okay. We'll set a material after we set the position. Okay, and now let's go on over to our shading, and let's create a material position, or let's create a material tree for this. So create a new material. We'll do an image texture. Okay. We'll do example image. Let's see if we can map. Okay, vector. All right, so let's do. We'll do geometry position going on into the vector. Okay, that doesn't do it, of course. So what we really need is we need to come up with our coordinates. All right. So fortunately, we have something we can use for this. I have a script that will add. Is it this one? No, it's the other one. That will add a geometry node that will allow us to get our r, theta, phi coordinates. Okay, so we'll do that here. Spherical coordinates. So we've got our positions. So we've got those positions, and now what we'll do is we will add a new named attribute on our geometry. It will be a vector type, and the name will be spherical coordinates. Okay, so if we look at this, we'll see that we've got r, theta, phi for all of these. So now let's go back into our material nodes. And let's see if we can map this directly onto r, theta, phi. So we've got our geometry position. We actually want a named attribute. This will give us a vector. All right, so we are going to use our texture coordinates here. Separate x, y, z. And we will get from that a color, which will go into our surface. Let's see, is that the right? That might not be the right thing to do. Now we are going to do got our separate x, y, z. We actually just need x and y. But we need y and z because r is not what we want. So we'll do y and z here. Okay. We've got attribute, vector into vector. Okay. Still not quite working. So let's see. We've got our x and y from our named attribute. Okay. Yeah, here we go. So we've got this color, surface, material output. Yeah. All right, so let's go back to geometry nodes. See what this looks like shaded. coordinates. Actually, you know what? I have a suspicion I'm doing something wrong. So let's go back to, because I think that I'm specifying what the color should be, but I'm not saying how the color should be applied to it. Let's go back here. We will do principled BSDF. One moment. Okay, so we've got principled BSDF. Let's try inserting our base color there. No, of course that didn't work. I don't know why I thought it would. So this again is where I am running into the fact that I don't know the exact right way to do these things. So now let's go map range. We'll map y from negative 3.141 to 3.141. Okay. Still nothing. Okay. Alright, so I'm going to see if I can figure out exactly what I'm doing wrong. Looks like maybe this is all where the UV stuff is where I'm supposed to pull into this, but I feel like I should be able to do it differently. So, scroll down to the mapping tab. So here's our example image, linear, yeah, clip, flat, box, nope, doesn't change it, of course. Flat, clip, generated. Right. So now we've got our surface here. Geometry nodes, material, all right. So let's see, down here, let's take a look at our preview. So here, displacement, render method, volume, fast. No, we don't want volume. Surface, volume intersection. Yep, looks like I'm. What? That looks very different. That must be it. Yeah, that's. Okay. So the color being fed in. It's being fed in as that. Let's see what happens if I just feed in a base color of that instead. Maybe it'll crash. Certainly seems possible. That's interesting. The preview looks different. Okay. Maybe image texture is exactly what I'm supposed to... Well, you know what? Clearly I'm doing something wrong. So let's go on back and identify what I can do right. Let's go back over here. We are going to do the next step, which I had avoided doing, which is basically... Oh wait, hold on. I've got a thing here. This is servo losing it for when I get frustrated.
Can you say something?
There we go. Okay, I don't know if that came through or not. So let's go back to our scripting, and here I'm going to identify if we need a new image or not. So let's see. In our scripting window, we can check bpy dot, and let's take a look at what our thing here is. Bpy dot data images. So let's see. Do we have example image? We do. Okay. Example image in bpy.data.images. True. False. All right. So now can we change the height and width of this? Takes no arguments. Okay, let's see. bpy.image dot. There's no set. So I guess we will have to figure out. We'll just have to assume that they're the same size. There's probably a way to do that. I'll come up with it in a bit. All right. So if example image not in bpy.data.images. Here, else img equals bpy.data images example image. All right. So now what I should be able to do is I should be able to reload this, execute it, and just see an updated image. So if I change it so that it's the blue that varies, go over to example. We'll see example image in just a second. Now if we go back to our shading, we'll see if it updated. Not yet. It did. Okay, great. So we do have an updated image. Great. Okay. So we've got that now. So the next thing we want to do is we want to come up with how we can modify all this and stay on the fly. So we've got our texture here. got our texture slots. So maybe I should try the UV editing. Maybe that's where this is all coming down to. Okay. So I don't want it cube mapped. I actually specifically want to query it manually. So the vector, material tree image, material tree image texture blender. So I'm going to Google this, see if I can figure it out. Huh. Alright, I think I found this out. Alright, so what I need to do is so I got to do a mapping. Alright, let's take, I've got my attribute. I'm getting a vector, spherical coordinates. I'm now taking separating out the x, y, z, but that's not really what I need to do. What I need to do now is I'm in the right view, or I need to be in the right view. So here, viewport shading, looks to me like my vectors are not being computed correctly. So let's do, we've got our map range, combine. We've got our vector attribute of spherical coordinates. Yeah, this is really killing my stream. I can tell. OBS is just not doing well. I didn't even think I was asking that much of the darn thing. So, got my image. I actually need to specify a vector that passes directly in here. So what I'm going to do is we are going to delete all of our input nodes, and we are going to query specific areas inside. Come on, you can do it. All right. What did I do? I really did a number on this. Okay, it's finally doing something. I guess what surprises me the most is that I'm doing stuff that I think is not super taxing, but apparently I'm doing something to make it extremely taxing. Oh, thanks, Paul. Thanks for stopping by. So I still can't figure out why. Appreciate you stopping by for those 10 minutes. So let's go ahead and try mapping this. You know what? Let's dump it back down to here for now. This might be enough to see things. So let's take a look. And it should improve my frame rate considerably. So let's do, we will input a value. Okay, so we've got our vector value. Man. Okay, so I'm going to map this value in here into the vector into that, and then the color into the base color. Oh, you can see that what I'm listening to, which is a YouTube video, but I wasn't actually listening to it. I just skimmed through it. That's fun. I never turned on music this time. Let me stop it. Okay. So now I should have these. Oh, is it this that's killing everything? My image preview? Is it trying to regenerate that constantly? Let's close that. Looks like it might have been. Okay. So if I do a value of wouldn't that be nice? All right. I should be able to do a value of 0.5 here. Well, I guess I put in 0.4. And I'll put in 0.5 here as well. And so now in principle it should be sampling identically everywhere. I don't know why I used an input value there. It should be sampling somewhere right around there. So now if I circle around, let's jump up over here to viewport shading. Doesn't look like it. Popping up here doesn't either. Okay. So I guess let's try, no. Let's do vector mapping. Let's try this. So we've got our vector. That doesn't seem to do it either. Well, alright, my time is just about done for today too, and I know that my viewer also has something to do. So maybe I will just call it here, and I will muddle through and figure this out at another time, because I don't think this is of too much use just yet, but hopefully it will be. Anyway, that's just my little adventure today. Thanks for stopping by. Thanks for stopping by, you guys. Thanks for breaking my cow lamp.